All right, we are live. So let me know if y'all can hear me okay in the live chat replay. So can y'all hear me okay? We've got Chris, Jeremy, Deadpan, Dave, Mike, Yanni, Aaron. Awesome. Y'all can hear me okay? Welcome. All right, so welcome to the Trading Bot Masterclass. So we'll get started here in just 1 minute or so. We're going to let everybody roll in. Let me know in the chat where you all are watching our presentation tonight. So we got Canada, Bama, Oakland, California, Ottawa, Canada, Los Angeles. We got Brooklyn, Atlanta, another Los Angeles, Ontario, Australia, Sacramento, Romania, Florida, Memphis, Texas. Was wondering, is it pre-recorded video? No, this is definitely not pre-recorded video. Eden, this is live. Montreal, Roseville, California, Jacksonville, Florida, Detroit. Awesome. Welcome. So we got lots of people in the chat here. Let's go ahead and get started. So welcome to the Trading Bot Masterclass. So I'm super excited to show you how to create a blockchain-based trading bot. So a lot has been happening in this space. I've been seeing crazy stories of, developers making insane amounts of money with flash loans with their trading bots. I don't know if you guys saw me make the videos about the developer who made $30,000 in a day, right, off his trading bot, or the guy who used the Bored Ape Yacht Club airdrop claim made like $820,000. It's pretty insane. Okay, so there's a ton of opportunity to flow around this space, and today I'm going to show you how to get the tools to pursue this opportunity yourself. Okay, so what we're going to cover tonight is everything you need to know how to create a blockchain-based trading bot, from the concepts all the way to the coding implementation. So we got some quick house rules before we proceed tonight. Definitely, stay inside the YouTube chat. We've got people from the Blockchain Mastery Program. We've got access to that community chat. If you're inside of there, definitely try to keep the questions in the YouTube chat. That's what I'm going to pay attention to tonight. And if you are a part of the, if you're not a part of the Blockchain Mastery membership program and you want to unlock other benefits like weekly videos, all the past master classes we've done, all the future master classes we're going to do, that community support chat, then definitely reach out to Gregory at dappuniversity.com and we'll get you taken care of. So, well, we've got a great chat section going on tonight. It's already lit up like a Christmas tree there. That's awesome. I'm going to be taking questions for our presentation tonight, but let's try to save a bulk of the questions towards the end of the presentation. It's going to be a lot easier for me to, not have to watch too many things at one time. I'll occasionally keep an eye on the chat, but I'm going to save a bulk of the questions for the end. So the other thing is, if you're watching this live tonight, it might be a little challenging for you to try to code along with everything live. So my best recommendation is try to get the big picture on the presentation tonight, and then, rewatch the replay, which you'll have access to, after the class, to try to work on the implementation. Okay. So, and definitely ask questions at the end. So let's see here. So, we're going to show you all this coding implementation tonight, so you how to set it up, so you how to run it. If you want access to the step-by-step program on how to actually, do a lot of the custom coding implementation, which is, what you're going to need to create your own strategies, then that the best way to do that is the Blockchain Bootcamp, and there is a link down below in the description to get your special discount for joining the presentation tonight live. Okay, so last but not least, I hate these disclaimers, but I always have to say there's no income guarantee for this particular class. We're not promising any type of financial return based on the knowledge here tonight. All right, we're holding this class by popular request to talk about how to create a crypto trading bot. So that's what we're going to focus on tonight, the skills and technologies that you need in order to do that. So I want to make sure we get all that clear up before we get started. So let's go ahead and jump into this. Okay, so let's talk about how this crypto trading bot works. Okay, so first of all, let's talk about let me just change my view here. Sorry. Change this for a second here. So let's talk about this crypto trading bot and what it does. Okay, so let's talk about what it does not do. All right, because this is a common misconception. So this crypto trading bot is not something where it's trying to predict future cryptocurrency prices. Okay, it's not like trying to say the price of Bitcoin right now is, $40,000. It's about to dip down to $39,000. So let's sell some and then buy it back. Okay. Those bots can work, but they often lose money. They blow up because they might work for a little while, but then usually it makes a mistake or you have slippage or something that ultimately causes the bot to lose money. So, what we're gonna do tonight is do a cryptocurrency trading bot that does not try to predict the future cryptocurrency price, but takes advantage of opportunities that exist right now on the blockchain with arbitrage. Okay, it's gonna be a blockchain-based trading bot that uses the open financial system to pursue these opportunities. So, what's the benefits of this? It does not try to predict the future. It seizes opportunities that exist right now on decentralized exchanges. It does not require any money to trade. Okay, so the caveat there is gas fees to pay for transactions. Okay, but in terms of the money that you're trading around, is not required to do that. And it can't lose money like this other bot can. Now, the other caveat there is the gas fees. So, attempting a trade that doesn't necessarily work, you could theoretically lose money on gas there. But the whole idea is you're not going to take a bunch of money, put it into a bot, and then just all that money is going to be at risk, like another trading bot is that's trying to predict cryptocurrency prices. Okay, so it's an arbitrage bot that basically looks at real-time opportunities right now, not predict the future. It uses smart contracts, so it's blockchain based. It runs on chain. It talks to different decentralized exchanges, buys cryptocurrency one place, sells it in a different place. It uses flash loans, and that's the secret sauce of not needing your own money in order to trade. And that's the other secret sauce of not being able to lose that money. That's how a flash loan works. Okay, so we're going to cover everything that you need to know, how to start creating your own, the comprehensive overview of how the trading bot works, the actual coding implementation, the setup of the bot, demonstrate how to use it and how to customize it for your own strategies. Okay. And then finally, we're going to focus on doing this on the Ethereum chain itself. Okay. And then you can take that knowledge and scale it out to any other EVM compatible chain because there's lots of other decentralized exchanges that work exactly like the ones we're going to show you tonight. Other cryptocurrencies have worked the exact same way. The real skill in using trading bots is basically learning how they work and then applying your own strategy. So that being said, what we're going to do tonight is teach you how to create a cryptocurrency trading bot. So I have done this class before where basically I just have a trading strategy and I just give it away. Okay. I've got actually a replay of that inside the Blockchain Mastery membership community. You can see that it's a live bot. It's got sample transactions in it inside of there, stuff like that. So there's a problem with that, is if I do that on this class and just give you the strategy, then everybody who has that strategy on this class is going to be competing with one another. And it's just going to be the strategy is not going to be as effective anymore because everybody's doing the exact same thing. They're looking for the exact same arbitrage opportunity. So let's talk about how to actually do arbitrage. There's two basic philosophies. One is you can try to be the absolute best. So if you have that strategy, what you could do is try to be the person who is the fastest, okay, and the most sophisticated and first, and then you would be the winner of that particular strategy, even if other people are trying to do the same thing. That's how some of the really big trading bots work out there. Okay. Now the other potential opportunity is to essentially look for things that other people aren't doing. Okay. And if you choose option 2, then basically your advantage is if you learn to create the bot yourself based on the information I'm showing you tonight, how to use the particular bot that we're going to do, how to customize it, how to change things so that you can implement your own strategies, then that's exactly what you're going to, see how to do. You're going to see the finished bot with the finished solution, customize it, see how it's going to work. we're going to use it to where you can run it inside of a simulation environment where you can actually fork the blockchain and actually see things happen in real time. And that's a great way to actually implement your strategies because you can recreate real arbitrage scenarios. You can write the code for past, arbitrage transactions if you want to do that. Think about kind of like a flight simulator. Like if you want to learn to fly an airplane, then you need to get into a flight simulator and do that before you, just get behind a 747 and start, carrying yourself across the Atlantic Ocean. So that's exactly what you're going to learn how to do tonight. So let's go over some of the concepts that you need to understand in order to make all this work. So I'll pull this up on my screen here. See if I can get this to work. All right, so let's look at the core concept that you definitely need to first and foremost understand before you can jump on this opportunity is, what is an arbitrage? Okay. So an arbitrage really of anything is just buying something, low and selling it high, or buying something for one price and selling it somewhere else at a different price. So this works with cryptocurrency because different cryptocurrencies sell for different amounts on different cryptocurrency exchanges. Okay, so what do I mean by that? So essentially, when you arbitrage cryptocurrency, that means you're buying it at one exchange. Let's say the token costs $100, for example, and then you sell it on a different exchange for $101. Okay. So this is an example of a arbitrage that is a $1 profit opportunity. Okay, which doesn't sound that amazing, right? It's just $1. But what if you could do this with a bunch of different units of the same cryptocurrency? Like, what if you could do this with 1,000 tokens, in one transaction? Well, that'd be $1,000 profit. All right. Or what if you could do it with a $5 difference, 100 times? So that'd be a $500 profit, right? So there's different ways to, increase the profitability of those small price differences. Whether it's, buying a lot of the same cryptocurrency or doing it over and over and over again. Okay. So, now you can do arbitrage, on regular cryptocurrency exchanges. We're going to do a blockchain-based trading bot tonight, powered by smart contracts. But let's say you wanted to get on Coinbase and, buy some Bitcoin and then go sell it on Binance because the price of Bitcoin on Binance is higher than the price of Bitcoin on Coinbase. You could theoretically buy some on Coinbase and send it over to Binance and then sell it, or maybe you could have a wallet on each exchange and then try to move the prices that way. But there's a problem. Like by the time you go from one exchange to another, the price can change on you. There's a lag time. Okay, so the cool thing about blockchain is that you can hook into each exchange with smart contracts and do the arbitrage in real time. So there's no latency. There's no way for the price to move on you because if you hook into each exchange, you can buy on one exchange and sell on the other exchange in the exact same transaction with smart contracts. Okay, that's the real amazing part of doing this with blockchain because each decentralized exchange is powered by smart contracts, and as a developer, you can hook into each of those. Okay. So let's talk about what makes this even more amazing, which is the concept of flash loans. So what are flash loans? Well, basically, this is borrowing millions of dollars of cryptocurrency for free with zero money down as long as you pay it back in the same transaction. Okay. So how on earth do you get a zero money down loan for free? Well, because blockchain, basically, there's no way that you can lose this money. Okay. So let me explain how that works. So let's talk about different types of transactions in blockchain. Let's talk about simple transactions versus complex transactions. So a simple transaction basically is, let's say that I wanted to send some cryptocurrency from my account to yours. Let's just say 1 Ether. I'm going to send you 1 Ether. It's a lucky day. So if I do that, that's a simple transaction. It basically just has one instruction or two instructions, I should say. Take Ether out of my account and put it into your account. All right, it's a simple transfer. Now that's a basic blockchain transaction. Now you could have more complex blockchain transactions that have multiple steps. Like step one is borrow money. Step two is do something with the money, like trade it on exchange. Step three is pay back the money, and then step four is keep the profit. Okay, so that's what a complex transaction is, and that's how you can actually take out a flash loan and do this all at the same time. And that's why you can't lose the money and you can pay it back, because when you're doing this with blockchain, you have access to the entire blockchain all at once. And if the trade is not profitable, then the transaction will revert and you can't be on the hook to lose any of that money. And so, as a developer, you have the ability to write these complex transactions with multiple steps, step 1, 2, 3, 4, by coding your own smart contracts. Okay. Because when you're coding smart contracts, you can create functions that do things like multiple steps where you can take out a flash loan and then trade on exchange and then pay it back and then keep the profit. Okay. So, there's lots of things you can do with flash loans. Arbitrage is probably the most common thing, and that's what we're going to use it for today. There's so much you can do with this. A couple caveats with the flash loans is, you can of course borrow millions of dollars of cryptocurrency for free with zero money down. But just because you can borrow $1 million doesn't always mean you have to, right? You could borrow smaller amounts. And then also, the caveat of zero money down, there usually is some sort of small fee associated with it, but sometimes the flash loans can be 100% free, or sometimes the fees can be so negligible it doesn't even really matter. Okay, so the free part really means no collateral, but sometimes there is a tiny fee, but you'll see later in this video it's pretty negligible. All right, so let's talk about ERC20 tokens. Okay, really quickly. So ERC20 tokens are a pretty critical part of how this works. So let's talk about ERC20 tokens. So the cool thing about Ethereum is it lets you create a cryptocurrency without creating a new blockchain with smart contracts with ERC20 tokens. Okay, so ERC20 tokens are just smart contracts that adhere to the ERC20 standard. Okay, these are tokens, like this is the standard that describes how the cryptocurrency should work, so they're compatible with like decentralized exchanges and wallets and all that type of stuff. Okay, so you can see really popular ERC20 tokens here: Tether, BNB, USDC. Lots of stuff: Shiba Inu, Chainlink, Uniswap token, all this stuff. Okay, these are all really famous ERC20 tokens. So, oops, sorry, pull this off here. So you can see example of the ERC20 spec here. All right, this is a example that has the function names, like the name, symbol, total supply, transfer from. And these are functionalities that you want to familiarize yourself whenever you're trading tokens, because that's going to be a pretty critical part of the arbitrage process, is moving tokens around, particularly like approving tokens and then transferring them and transfer from. Okay, it's a really great idea to familiarize yourself with this ERC20 spec, because that's what we're going to be arbitraging. We're going to be arbitraging different ERC20 tokens on decentralized exchanges with our trading bot. So now let's actually talk about decentralized exchanges and how they work. Okay, so we're going to look at different decentralized exchanges like Uniswap, for example. So Uniswap is a decentralized exchange or a DEX. It's one of the most popular applications on top of Ethereum. Let's look at the basic architecture of how a decentralized exchange works. So you can see like an app like Uniswap has a website, okay? And then that website's where you connect your wallet to do the trading. And, that connects to a smart contract called an automated market maker. That's where all the trading activity happens for Uniswap. But then it connects to these things called liquidity pools. Okay. So let's talk about those and how they work. So what is a liquidity pool? Well, let's look at this. So if I ever get on Uniswap, like right here, and then let's say I wanted to swap, DAI for some other token. Let's say this Aave token, right? And I tell it I want to swap 100 DAI, and then it's gonna, fetch me the best price, and it's gonna give me this many Aave tokens back. Well, if I have DAI in my wallet and it gives me these Aave tokens back, and I click connect wallet and then swap, sign a transaction MetaMask, where do the Aave tokens come from? Right? Where are they? This is sort of like a vending machine where you just put tokens in and different tokens come out. But where are those tokens located? All right. Where do they come from whenever you do the swap? Well, they come from these things called liquidity pools. Okay. So again, we saw our website that talks to a smart contract that's called the automated market maker, but then that talks to these liquidity pools where all the cryptocurrency is parked. So if I was going to be trading for Aave tokens, there's some Aave tokens actually sitting inside of a liquidity pool. Okay. And similarly, there's WETH tokens inside that lets me trade stuff with a common pair of ETH. Okay. So let's talk about that. So where does that cryptocurrency come from? Well, it comes from people who park their cryptocurrency in these liquidity pools to earn a passive income reward. Okay. So basically, these are called liquidity providers, and liquidity providers put their ETH, or not just their ETH, but their tokens inside these liquidity pools, and they're incentivized to do this by earning a passive income reward for that. So they're providing liquidity to the app gets liquidity, they get passive income. It's powerful, decentralized incentives at place. Okay. And you can see these trading pairs like USDC WETH or SHIB WETH. So the cool thing about this is, as a developer, you have access to all these smart contracts directly without having to use the website, right? So if I got on Uniswap a second ago and was able to swap tokens through the interface, connect my wallet and click a button, you could do all that through the user interface. But those smart contracts that power that app are all 100% public. They're all on a blockchain. And you as a developer, as long as you can hook into those smart contracts, you can use them. And that's exactly what you do whenever you create these trading bots. You hook into the interface of those liquidity pools and these smart contracts with your own smart contracts, and you do the trades that way. Okay. So you just have to, implement your connection to the exchanges and your own tokens. So one thing while we're here, one thing I want to note is some people wonder, where does the money come from when you're doing flash loans? Like where does the loan money come from? Well, it comes from these liquidity pools. That's where it comes from, because these pools are just sitting there. They're being used inside these DeFi applications, but many times they have the secondary functionality of being able to, essentially have loans taken out. Somebody says, pretty simple, already learned these things, waiting for the cutting part. Yeah, we're going to get to the cutting part. We just want to make sure that everybody's starting with a solid foundation before we start getting too deep in the coding. All right, so that being said, let's take a look at how the bot works. So, first of all, you're going to write a smart contract that talks to each cryptocurrency exchange, just like I was talking about a minute ago. Okay. It's going to have exchange A, and it's going to have exchange B. And essentially, your contract's going to hook into each of those. It's also going to hook into this flash loan provider. Okay. And so each of those exchanges is also going to have an ERC20 token. All right. Like this right here, like the Uniswap token, all right, or the SHIB token, right? So exchange A is a decentralized exchange like Uniswap or SushiSwap. It's got tokens on it. You're going to buy token 1, an ERC20 token on this exchange, take it to your contract, and then go to exchange B and then sell that token. Okay. So the prerequisite step, though, is you're also going to hook your smart contract into the flash loan. Okay. There's different flash loan providers, like it's a smart contract itself, like DYDX, Aave, Uniswap, Dodo. We can talk about those later. All right. So your contract takes out a flash loan, hooks into this exchange, buys the tokens, sells on this exchange, takes the profit, pays the loan back. Okay. And so all the stuff below this line lives on the blockchain itself. Okay. So your smart contracts on the blockchain, the exchanges are on the blockchain, the tokens on the blockchain, and the flash loans on the blockchain. All right. So, other thing is you're trading your contract as a Solidity smart contract. Okay. We're going to do this on Ethereum tonight. This can be applied to any EVM compatible chain, Polygon, Avalanche, Binance Smart Chain, doesn't matter. Anything that supports Solidity, you'll be able to apply this for. This is the contract that enforces the rules for the flash loans. You can't lose money, all type of stuff, right? But above the blockchain is your bot. So what is that? Well, the bot is basically like an app or a script that sits there and listens to different exchanges, okay, and actually checks the price, okay, and that's what watches this contract and then fires a transaction to the contract whenever it finds an arbitrage opportunity. It's like a watcher, okay. The bot that we're going to do tonight is actually written in JavaScript, so it's two parts: the bot code, the JavaScript code, and then the contract that does the trading and takes up the flash loans is written in Solidity. And that's on the blockchain. So this is either on your computer or in the cloud, and this right here is on the blockchain. So your bot, how it's going to work is basically what it's going to do is it's going to listen to different cryptocurrency exchanges, and it's going to listen for every single, like when you're going to subscribe to a trading pair, okay? And every time a swap is made on those trading pairs, it's going to find out about that, okay? And then whenever it finds out about that, it's going to check the price differences for different cryptocurrency exchanges after that swap event takes place. Because on these automated market maker chains, on these automated market maker dexes, the only time the price would change is whenever a trade happens. So every time a trade happens, it rechecks the price to see if there's any discrepancies. And if it can profit, then it's going to call the contract, okay? And if it cannot, it's just going to wait and see there's no arbitrage opportunity. It's just going to pass. Okay, so that's your bot. That's the top part, like we saw here. That's what it does. Now, let's talk about your contract right here. So your contract is actually going to do the trade. It's going to take out the flash loan for token number 1. It's going to buy token number 2 on exchange A with token number 1. It's going to sell token number 2 on exchange B for token number 1. It's going to repay the flash loan back with token number 1. And then it's going to keep the profit of token number 1. All right. All right, so let's talk about sort of the big opportunity here. All right, and this sort of sets you up for seeing the strategy. Here. So, like I was talking about before, when you're talking about arbitrage, there's a few ways to sort of compete. All right. you can try to compete and be like the fastest person, okay? Or you can just try to do something that like nobody else is doing. All right. That's kind of the two different philosophies. Now, my recommendation is to try something that other people aren't doing. Okay. I'm going to show you sort of like how that works. So part of it is all the variables. Um, Part of it's all the variables in the equation. Okay. Because there's so many different cryptocurrencies, there's so many different exchanges, and then now there's getting to be so many different blockchains. Okay. So first of all, we saw this list earlier about how many, ERC20 tokens there are. I mean, there's 20 pages of just this, and that's just for on Etherscan. There's a lot more ERC20 tokens than that. This has 523,000 token contracts found like on Etherscan alone. Right, doesn't include other EVM compatible chains. You look at talking about decentralized exchanges. Okay, we've got a massive number of decentralized exchanges. Okay, this is you know 208 on this one page alone. Okay. And now we're also talking about other EVM compatible blockchains, okay, with lots of forks. You can see many an EVM compatible chain right here. Um, you can look at the chain overview. And so the whole idea is that, you can look for new opportunities by changing the variables, the tokens, the exchanges, the flash loan providers, the chains that you're looking for the opportunities on. Um, there's just so many different things that you can tweak in order to essentially create one of those strategies to look for opportunities that other people aren't doing. And one way to do that is also to look for different tiers of opportunity. Like I said before, just because you can borrow $1 million of cryptocurrency doesn't mean you have to. You might be able to focus on smaller arbitrages, doing them more often, basically getting it right, and then refine that strategy, or just doing what's working over and over and over again. So the other thing about the other blockchains, there's so many different EVM compatible chains, and that's what I wanted to um, mention is like we've got Avalanche, Binance Smart Chain, Polygon, Matic, Phantom. The list just goes on and on and on. And the cool thing about a lot of these EVM compatible chains, we also have Ethereum layer twos. Okay, Optimism, Arbitrum, where you can deploy Solidity smart contracts to all these things. So if you can write code for Solidity, you can put it on any of these environments. Okay, now you'll have to change some settings based upon the contract addresses, and also if the flash loan providers work differently on those networks, you'll have to change those as well. Okay, if there's a difference in there will be some differences, but that's the whole point, is learning how to do it and then being able to implement on those things. So the other good thing about this is a lot of these environments have lower gas fees. That's one of the big objections to doing something with Ethereum mainnet, is that the gas fees prevent a lot of arbitrage from being profitable. But you can greatly reduce that problem with other lower cost chains. So let's talk about some flash loan providers really quickly. Some different options. So there are lots of different flash loan providers out there. I'm going to throw a couple at you tonight. We're going to use a particular flash loan provider tonight, but I'll give you some options so that if you want to move this around different chains or just have some different options, you'll see what they are. So some different flash loan providers are Aave. Okay, Aave is one of the first people to do flash loans. You can basically, Aave is a money market Dapp. Okay, they have liquidity pools. People can deposit cryptocurrency, borrow it, and they can. They have flash loans built into that application as well. You can do them with DYDX, okay, so their decentralized application. This is the flash loan provider that we're going to use tonight. One reason I like DYDX is because it's one of the simplest interfaces to use combined with the lowest fees. Okay, that's a really nice feature of DYDX flash loans. Obviously, it's got a little bit higher fee. There's also Dodo. Okay, Dodo lets you do flash loans for free. Although I do find the Dodo interface for flash loans to be a little more tricky than getting it to work with something like DYDX. So DYDX is definitely my go-to for doing these as well. So I see a quick question on the bot. Is the bot always running? Can you put it on a server so it can always run? Yes, you can definitely do that. So does Ganache work for other environments? Is there Ganache Shuffle equivalent to Phantom or AVAX? You can basically use Ganache for those other environments. It works the same way. All right, so let's look at the specifics of the bot that you're going to use tonight. All right, so we saw this kind of high-level overview here. But let's look specifically how we're going to do it. All right. So your bot is going to exist here, right? It's going to be this app that essentially is written in JavaScript that watches the blockchain. You're going to have your smart contract here, okay, on chain. And, we're going to show you how to reproduce a flash loan for real in this class, okay? And this can be hard to do in the wild. Basically, I could sit here and try to wait for a flash loan opportunity to pop up, but it would be hard to time that, and guarantee that we could show that like on the class. So what we're going to do is show you how to create a simulation where you can do it yourself in a sandbox environment. Okay. And I can actually reproduce it on the class tonight and show you how to do it so that you can customize it and create your own strategies. So, we're going to keep it as simple as possible. And so what we're going to do is your bot's going to be here. We're going to do this on the Ethereum environment. Again, you can apply this to other chains, other EVM compatible chains. And your contract's going to hook into two different exchanges that basically work the same way. So Uniswap version 2, okay? So Uniswap version 2 and SushiSwap. So why have I chosen these? Because, well, number one, Uniswap version 2 is the exact same code as SushiSwap, basically, from an interface perspective, okay? So basically, if you know how to make trades on Uniswap version 2, you know how to make trades on SushiSwap. And spoiler alert, if you go to, an app like this, DeFi Llama, and you look at, let's just see here, forks, then you can look at all the Uniswap forks, and there's 248 Uniswap forks. So I'll just leave that there as a hint. Okay. So there's a big value in knowing how Uniswap version 2 works. So that's exactly what we're going to teach on the class tonight, is how to use Uniswap version 2 and against SushiSwap on the Ethereum network. But again, this could be applied to any fork on any other network, like, Pancake Swap or Trader Joe, right? Just a little hint for you there. So what cryptocurrencies are we going to be arbitraging? So we're going to be arbitraging WETH tonight. Okay, so WETH, what is that? It's wrapped Ether. So it's an ERC20 token version of Ethereum, or the Ether cryptocurrency. Okay, so we're going to arbitrage WETH, and we're going to be taking out flash loans from DYDX for WETH itself. All right. And then we're going to be arbing Shiba Inu tokens, or SHIB tokens. Okay, so basically we're going to take out a flash loan for WETH, buy SHIB tokens, on, Uniswap, and then sell the SHIB tokens on SushiSwap back for WETH, and then pay the flash loan back and then take the profit. And I'll do this all on the Ethereum chain. So you'll see that flow here. Basically, we'll take the loan out from UIDX. We'll take out WETH. We'll trade WETH on Uniswap for Shiba tokens, or we'll buy Shiba with WETH, or we'll sell WETH for SHIB, depending on what you think about it. Then we'll have Shiba Inu tokens, and then we'll sell the Shiba Inu tokens on SushiSwap for WETH, and we'll pay back the loan, and we'll take the profit. So let's talk about how we can recreate this ARB scenario. Okay. So earlier I was talking about one of the best ways to practice, is to learn to create your own strategies and do it in an environment where you can actually reproduce an arbitrage scenario and make sure that your bot works. Okay. So the best way to do this is to create a sandbox environment for yourself where you have access to all the blockchain data, and you can essentially work with all that blockchain data and, come up with arbitrage opportunities and manipulate it. So we're going to do something called forking the Ethereum mainnet on our local computer. So what we're going to do is actually get a copy of all the Ethereum data, like all the apps, all the all the decentralized exchanges, all the tokens, everybody's account balances. We're basically going to get a snapshot of all that on our computer. We're going to freeze it in time so that we can manipulate it and then actually do stuff like spend money, unlock accounts, make trades, and just pretend like we're using the real blockchain, but we're not actually risking any money while we're doing that. So how do you do that? Well, we have a really cool thing called Ganache, which is a development blockchain on a computer, and we can point Ganache to the blockchain, okay? And then we can basically say, hey, freeze the blockchain on our computer so that we can, we can interact with Uniswap, pretend, right? And actually make trades and do all that type of stuff. We can unlock all the accounts on the network. We have access to all the smart contracts, the balances, the tokens, exchanges. All we have to do is basically get a URL to an Ethereum node. In this case, we can use Infura, Alchemy, whatever it is. We can use somebody else's Ethereum node and just connect to it with our local blockchain, and then connect our smart contract that's a part of our trading bot setup to this simulator so that we can write the code that actually makes trades and does arbitrages. And we can basically, set up an arbitrage scenario by manipulating different prices on cryptocurrency exchanges so that they actually fall out of sync, and that our bot will detect that. And then we can fire off the arbitrage and see that it actually happens. Okay. That's how you learn, basically, is you create a bot that's supposed to capitalize on an arbitrage opportunity. And, you can recreate an arbitrage opportunity on your computer, so you have to wait for it, so that whenever that scenario arises, you'll know that your bot works because you've actually tested it out. Okay. So let's talk about how we're going to do this, how we're going to create a arbitrage scenario. So we're going to arbitrage with the Shiba Inu token, right? We're arbitrage WETH and Shiba Inu tokens. And since we have access to, the entire blockchain once we freeze it on our computer, we're going to take this Shiba Inu wallet and we're going to unlock all the tokens from its account. And we're going to dump all those tokens on SushiSwap, okay? And so what that's going to do is it's going to cause the price on SushiSwap to go down like crazy, because when you spend that many tokens at once, you trade them, it causes all this slippage, okay? Whenever slippage, the price goes down like crazy. And then now Shiba Inu is going to be incredibly devalued on this exchange, which means it's going to be cheaper here and more expensive here. So that basically means that there's going to be an arbitrage scenario for somebody to come buy low on SushiSwap and then sell high on Uniswap, because that's how arbitrage opportunities happen. They happen either because, slippage happened from a big trade, or sometimes, the cryptocurrency markets themselves are volatile And so you're going to have these arbitrage opportunities just occur naturally because cryptocurrency prices are moving so fast, and the markets need to be brought to efficiency. Okay, so let's talk about a couple more concepts before we start coding. The last question I'll get a lot is like, how much can you arb in this situation? So, just because you can borrow millions of dollars of crypto doesn't mean you'll be able to use that much when you're trading. So you're going to be limited to basically the amount of money in those liquidity pools. So earlier I talked about, that's where the cryptocurrency is stored, inside the liquidity pools. Okay. And so basically, like, um, you're gonna however much crypto is inside of there will determine how much you can actually arb. So I'll show you an example. So if you look at, let's just look here. I'm gonna pull up these pools so you can see what I'm talking about here. All right, so here we go. So I'm actually gonna pull up a real live liquidity pool here, so that you can see it. All right, so right here is a Uniswap version 2 pool for Shiba Inu tokens and WETH. So if you want to trade Shiba Inu tokens on Uniswap version 2, it's going to go through this pool because there's an equal amount in US dollar terms, basically, of wrapped Ether and Shiba Inu tokens. Okay. Actually, there's a small price discrepancy here. There's about $5,000 difference. So I wonder if we'll see a opportunity happen there. Anyways, there's a small price discrepancy. That there's basically $3 million in this pool for each token. But on Sushi Swap, there's $2,000 basically of each token. So the question is always going to be, how much can you arb? We're talking about how to take a flash loan, how much profit can you make? Well, basically, the smallest reserve is going to be the limit. All right, and so that's how these pools work. They determine the price, based on the ratio of tokens inside of there. So if there's 5,000 Shiba tokens and 2,000 WETH, that means there's 2 Shiba per WETH. And over here, if there's 1,000 Shiba tokens and 1,000 WETH, it's 1 Shiba per WETH. Okay, and so that's how you find out what the price is. The prices are expressed in a ratio of the 2 different tokens that you're trading based on how many are in each liquidity pool. Okay, and so you can see that here. All right. So you can say that each token is about this much in terms of US dollar, but you could express it like that. Okay, so the last thing I want to talk about is calculating the profitability of the arbitrage opportunity. Okay, so whenever you're doing the arbitrage, of course, you're going to buy low and sell high. But when you're talking about, let's say you could buy 100. Let's just say you could arb, 100 Shiba tokens in this case, from Uniswap to Sushi Swap or vice versa. Well, you'd have to, you can't. It's got to be profitable in multiple levels. So just because you can get tokens back, profitably doesn't mean it's going to be a profitable trade. You also have to pay the gas fees, okay, in order to make that profitable, and you also have to pay the flash loan fees, if there are any in that particular situation. So you have to do some calculations. You'll see that inside the bot, later today. Okay. And then, so the caveat here is there will be many times where it looks like there's a profitable arbitrage opportunity, between two different cryptocurrency exchanges, but the gas fees will actually prevent that from happening, especially on, chains like Ethereum when the network is at peak congestion. Um, so, you have to calculate that out before you try to jump on those opportunities. So just want to make that caveat so everybody's clear about that, before we jump into the coding part. All right, so let's go ahead and set this bot up, and yeah, let's go ahead and get started. Let's go dive into the good stuff. All right, so there should be a link down in the description below wherever you're watching this video. If you're watching a live presentation tonight in the YouTube chat, there should be a zip file, um, for the code where you can download it and unzip it. Okay, I'm gonna be referencing this GitHub repository tonight with the README inside of it. You won't be able to access this GitHub repository; it's private. Okay, but you should have a zip file, down below where you can download the code and unzip it. So once you've done that, go ahead and open your terminal here. So, there will be a few dependencies that you need in your computer in order to run this locally. All right, you're gonna need, Node.js installed. Okay, first and foremost. So let's see. I'm using Node. Let's see here. Node version 14.16.0. Okay, so I just ran through this a little while ago, and I confirmed that version does work properly. I actually had a problem with a different Node version, so if you have an issue, then definitely check out that specific version of Node to make sure that everybody's on the same page and their bot runs properly. Okay. You also need to have Truffle installed in your computer. So I'm going to say Truffle version. Truffle is what we're going to use to develop the smart contracts in this presentation. Okay. I'm using Truffle version 5.5.11. If you don't have Truffle installed, you can do npm install -g Truffle, say at 5.5.11. Okay. I also use this specific version because I had a little bit of a problem earlier when I ran through it. So make sure you install Truffle with the right version if you have issues. And then finally, we're going to install Ganache on our computer because that's what we're going to use to fork the blockchain. So if you can see if you have Ganache already installed like this, Ganache version. Okay. So that's version 7.1.0. So if you don't have Ganache installed, you can just do npm install -g Ganache. Okay, and that'll work. So I've already done this step, so it's not going to have to again. All right, so once you've opened the code in your terminal here, you want to do npm install. All right, that's going to install your packages locally. All right, so I've already done this step, so it's going to just tell me I'm finished, and it'll happen quickly. All right, but for you, it'll probably take a couple seconds the first time. Okay, so now what we want to do is let's just go ahead and open the code. All right, Sebel dot. and you'll see the code for everything. All right, you're going to see truffle-config file. This is what sets our project up and points it to our development blockchain. Okay, you can see the smart contracts inside of here. You can see this arbitrage smart contract. We'll go over that here in a little bit. Okay, you can see this bot.js file. Okay, this is going to be the main script file for our bot that actually watches the chain and calls our smart contract. Okay, and yeah, there's a lot inside of here. But let's go ahead and set up our sandbox environment, because remember before I was saying that we wanted to create an environment where we could fork the blockchain and actually get access to all the smart contracts and the accounts and stuff like that on side of our computer, so that we can, interact with, you know, the exchanges and the tokens and all that type of stuff. So we're going to use Ganache to do that. All right. So I showed you a second ago, we installed Ganache. You can start Ganache with a really cool feature called the fork feature. So first of all, let's just show you Ganache. If I do Ganache like this, what it's going to do is it's just going to boot up a local blockchain on my computer. Okay. And so if I do Ganache, you can see it there. All right. But the cool thing about Ganache is, so right now, this is just a sandbox blockchain. It's not connected to the real blockchain. It just gives me like all these 10 accounts for free with, 1,000 fake ether inside of them. All right. And you can see their private keys. You can see the seed phrase for this wallet. Again, don't use these private keys or this seed phrase for your own cryptocurrency, because everybody's watched this video is going to take that and run with it and, take your money. So, but we can actually start up Ganache with a special setting that connects it to the real Ethereum mainnet, so that we can access applications like Uniswap, SushiSwap, the Shiba Inu token, the WETH token, and get access to those account balances and actually do trades that way. Okay. So I'll show you how to do that. Basically, we're gonna let's go ahead and take the mnemonic seed phrase that happens whenever you open Ganache like this. Okay, so again, don't use this for real, because that's someone could steal your crypto. But I'm gonna say Ganache -F, so that's what the forking option is, and then you can tell it your mnemonic seed phrase, which is what I'm going to use, because I want to start it with the same private keys every single time. I don't want to just randomize it every time I restart Ganache. So I'm going to put in the private key. I'm going to put in the -M, paste in the mnemonic. I'm going to put in quotation marks there. Okay. And then I'm going to say -U. So what is that? So -U unlocks a very specific account. So what you can do is, if you unlock an account with Ganache, you'll be able to act like that account inside your project and do things like, sign transactions, spend tokens. So what we've done, we've actually taken this account here, and let's just take a look at it here. We found this account on Etherscan that has a ton of Shiba Inu tokens. Okay. So it's got $9 billion worth of Shiba Inu tokens. All right. And so we're going to unlock this account so that we can actually spend the Shiba Inu tokens in our flight simulator environment. Okay. Because before, remember, I was talking about how we're going to set up an arbitrage scenario is we're going to take a large Shiba Inu wallet and we're going to dump all their tokens on SushiSwap to make the price fall out of sync. And then we're going to buy up tokens on SushiSwap and sell them on Uniswap. Okay. So in order to do that, we need to unlock their account. So I'm just going to, copy that, it's directly, it's inside the, the README here. Okay, unlock it, and then finally going to do -P 7545. That just specifies the port that we want to run on. Okay. All right, now we've got our development blockchain running pointed to the Ethereum mainnet. You can see that here, Ethereum mainnet via Infura. So it just uses Infura out of the box. You can see the latest block. Okay. If you want to use a different, RPC provider for some reason, okay, you can use one like this. Let's say you have an Alchemy node or some other node provider. You can do it like that. But Ganache supports Infura out of the box. And we can just point it directly to that without having to bring your own, URL. All right. So the next thing we want to do inside of here is look at this .env.example file. Okay. So what you want to do is duplicate this file and then say call it .env. All right. So just copy and paste everything that's inside of here and create a new file here called .env. So not .env.example. I'm not going to show you my .env because basically yeah, it's just sensitive information. So what you want to do is go ahead and fill this out. So what I'm going to do is basically copy and paste this. For now, you want to do arb4 and arb against, leave those there because right now we're going to arb for, WETH tokens, which is this address, and arb against Shiba Inu tokens. So that's this address. If you want to change these tokens later, that's where you change it in the settings. The account, I'm just going to copy and paste the, I'm going to copy and paste the first account from my Ganache address here. Okay. Price difference. This is just going to be the price difference that we want to look for. You can see the description here. The difference between twice between Uniswap and SushiSwap. The default is 0.5%. Okay. So the account is going to be the account receiving the profit. This is the WETH token. This is the SHIB token. For Alchemy API key, you only need to do this if you are actually going to run the bot in production. So I'm going to tell you how to do that really quickly. So if you want to run the bot in production, then create an account for Alchemy. That's going to give you access to an Ethereum node. You can create a new app inside of there, get the API key. You can just copy that API key and then put it inside of your .env file with the API key right here. Okay. So units is going to be for price reporting. We can leave that at 0. So gas limit's going to be this amount right here. So this is currently just a hard-coded value. Okay, you can adjust that during your testing of the bot. And then the gas price. Okay, we're just going to do a hard-coded gas price. You could upgrade your bot to actually fetch the gas price live, or you could adjust it, with different settings based on chain conditions and all that type of stuff. So yeah, you can change those settings here. So anyways, you want to fill out your .env file. Again, this is just the .env example, okay? So I'm going to just move my account here. You want to do it in the actual .env file, not just the .env.example file. You want to create a new file inside of there. All right, and save that. Okay. So now we want to do is go ahead and run it. Okay, let's just go ahead and run it, see how it works, and then we'll actually go through and explain the code itself. So what I'm going to do is leave this terminal tab open here. All right, and then I'm going to open a new window here. Okay, I'm going to put these side by side. All right, so in this tab, I'm going to clear and then do a new tab as well. Actually, let's do this. I'm going to leave the blockchain running back here. Okay. And the next thing I want to do is I want to actually take the smart contract for the trading bot, which you can see here, arbitrage.sol, and I want to go ahead and put it on the blockchain. All right. So we're going to explain this code in a little bit. Don't worry about it yet, but this is the contract that we need to put on the blockchain in order to do the arbitrage. Let's just demonstrate it first, then we'll explain it. So I'm going to put the blockchain like this. I'm going to say truffle migrate -- reset. Okay, it's compiling the contracts. And boom, there you go. It has been deployed to the blockchain. The arbitrage smart contract is put on Ganache. So you can see the output here on the blockchain. Okay. Here's a transaction, contract created, transaction. All right, transaction. Okay, done. So that's the first step. All right. So now what we want to do is actually start the bot. Okay, so we've got the blockchain running. Let's go ahead and start the bot. We'll start the bot over here. So we can do that like that. We said node scripts and bot. Actually, no, it's this. It's let me see where it is. Hold on. I moved it. Node bot.js. So node is what you do to start a node script, and our bot script is inside of here. So top level bot.js. This is the script that has a main function that just, checks for the bot, checks for the arbitrage. Okay. And so let's just run it. Okay. So the bot has started. Now you can see the bot's not really doing anything. All right. And that's okay. We don't want it to do anything yet. What we're going to do here is the bot is just watching the blockchain. And because we've frozen the blockchain on our computer, like nothing's happening right now. Okay, nothing's happening. So what we want to do is actually make something happen. Okay, there's no trading happening right now because we've frozen the blockchain. And so we want to actually observe the bot working. This is the whole idea, is to create an arbitrage scenario so that you can guarantee that the bot will actually fire whenever an arbitrage scenario happens. So again, we're going to recreate this scenario where we take this large Shiba Inu wallet that we unlocked, right here when we started the blockchain, and we want to perform a swap with that wallet and dump all their tokens on Sushi Swaps. Their price discrepancy will actually take place, and we can do that arbitrage. Okay. So how do we do that? Well, we have a special script inside of our app here that actually does that. So I have a script called manipulate price. So what it does is it takes this unlocked Shiba Inu account here, and then it actually does a swap on Sushi Swap, and it just dumps tokens on there, which makes the prices go out of whack. Okay, so we're gonna run this script, and whenever we run that script, manipulate price, it's gonna make the prices fall out of sync on the blockchain, and our bot's gonna detect it, and it's gonna perform the arbitrage with flash loans, and we'll be able to verify that it's happening in real time, because I'm gonna do this in two different terminal tabs. I'm gonna keep the bot running here, and then I'm gonna do the manipulation in this screen, and we'll watch the bot actually fire like this. Okay, so make sure we just look at the blockchain running. Okay, we're good. And then I'll say truffle exec. Okay, so this is just a truffle command. Actually, let me make sure it's going to work with the truffle. Let's just see here. No, let's not use truffle. Let's use node. Sorry. So let's say node scripts manipulate price.js. All right, let's watch it happen. And you can see this. All right, boom, there we go. Sorry, I lost my window, but you can still see that it happened. So basically, you can watch the output coming up, basically waiting for swap event. So swap initiated on Uniswap. We saw that happen. All right, so we check the price. Here's the current block. You can see the unit SHIB to WETH price on Uniswap, and then the SHIB to WETH price on Sushi Swap. And you can see this massive percentage difference in price. I mean, this is kind of a far-fetched arbitrage scenario because you hardly would ever see that big of a price discrepancy, but hey, this is just going to show you that it actually works. So then it determines a trade direction. So potential arbitrage direction is buy on Uniswap and then sell on SushiSwap. So then the bot calculates the profitability. So it checks the reserves here. Okay, here's the amount of Shiba tokens. Here's the amount of WETH. All right, so estimated amount of WETH needed to buy enough SHIB on Uniswap is this. Okay, and then the estimated amount of WETH returned after swapping SHIB on Uniswap is this. Okay, so this is the estimated amount of WETH that you'll come back with. This is the estimated amount of Ether that you would spend on gas for this trade. Okay, and then this is the total amount that you would gain after you take the ETH amount away from the WETH profit. So then it attempts the arbitrage and it completes the trade. And then you can see the actual total here. This is what the estimate is. This is what the actuals were. Okay. And then you can see that the profit that was taken here, even after the flash loan fees were paid. So it actually worked. Okay. So now let's dig into how this works and how you can, customize it and change it for your own purposes. Okay. So let's dig in first to the arbitrage contract. Start with arbitrage.sol. So let's see what's inside of here. So basically, let's go down to the very bottom. All right. And then look at line 149 all the way to the end. So this contract is a Solidity smart contract that does the arbitrage. And so it uses flash loans. Okay, it uses the DYDX flash loan in particular. So you can see the DYDX flash loan contract has been imported into our project here. Okay, it's got all the settings pulled up for the DYDX pool. Okay. You can borrow, whatever cryptocurrency is supported inside of here. Inside of here, we're doing WETH, okay, for simplicity's sake. WETH's the easiest one to borrow and work with and swap other cryptocurrency exchanges, okay. You can see that it implements the Uniswap version router, which we've pulled in at the top with this import right here, okay. We use that for SushiSwap router and also the Uniswap router because it's the exact same code, basically. All right, but then we provide the addresses for it, the Uniswap router, the SushiSwap router addresses. Okay, but we have the code for it inside of our app so we can make the trades. We have the owner address, which is the person who deployed the smart contract who's able to actually execute the trades here. All right. And then we have this execute trade function. So let's see how it works. So what we do is we have a Boolean value that says, do we start on Uniswap, yes or no? Token 0, which is the token that we're arbing from. The token 1 is the token we're arbing against. And the flash amount is the basically the amount of money we're taking out with the flash loan in order to make the trade. Okay. So that calls this flash loan function. Okay. So, where is flash loan coming from? Well, you can see that it's coming from, our DYDX library here. So you can see DYDX flash loan. This is how you actually do a DYDX flash loan. You pull the contract into your app here. You call flash loan. Okay. Now, you don't have to understand how everything inside this function works. Frankly, I don't understand how everything inside this function works. That doesn't matter because it's just a library. You just pull it in so you can use it in your own contract. But the bottom line is this asks for a flash loan from DYDX. You have to tell it what token you want, how much, and then any data that you want to send into the callback, okay? And then when DYDX actually gives you the flash loan, you have to implement this function in your smart contract called call function because the DYDX smart contract needs to have this function on your smart contract so that it can actually give you the flash loan. So you implement call function here. It has the address of the sender, the call data that you just packed in right here. All this stuff, this data. All right. And then, yeah, all that stuff. Okay. And then basically, everything that you packed in here, you unpack here. So start on sushi swap, token 0, token 1, flash amount, balance before. All right. You break those out into variables. And then you see the balance after. This is when you've actually got the flash loan. Okay. So once you have the flash loan, now you actually have money. And so this is where you sort of use money here. Now, everything below here is about actually doing the cryptocurrency trade itself. Okay. So I'm going to show you the secret sauce here. Okay. Excuse me. On Uniswap version 2, there's a special function here called swap exact tokens for tokens. All right. So this is the function that basically lets you trade on Uniswap version 2. Is you swap exact tokens for tokens. You tell it how many tokens you're going to put in, how many tokens you want to get out, the path, okay, and then the address too, and then the deadline. All right, so you can see it swapped the exact amount of tokens. You can see, all right, the amount of tokens to send, minimum amount of tokens that must be received. All right, the array of tokens and the address. So basically, this is the pair. Right, the path length must be greater than or equal to 2. Okay. The recipient of the output tokens. All right, and then the Unix timestamp after which the transaction will revert. Okay. So basically, we calculate this is in a swap on Uniswap and swap on Sushi Swap. So again, Uniswap version 2 router works on Sushi Swap and Uniswap. So we have this swap on Uniswap function. It works basically like the swap on Sushi Swap function. The only difference is this one calls on the Uniswap router, which we saved up here. And then the other one calls on the Sushi Swap router, which we saved down here. Okay. So it's really important. That's how a trade happens. Like this is basically just trade on Sushi Swap, trade on Sushi Swap. Okay. And you can see that it uses this particular function underneath the hood. All right. And then we did the flash loan with DYDX with that flash loan function that's getting passed back here. So inside the call function, like I said, the callback, let's just go through and look at this a little more. So basically, you can see we set up the path here for the trade. Okay, that's what the array here is. Token 0 is going to be the first token in the path. Token 1 is going to be the second token in the path. The 0-base index array start with 0, then 1. And if we start on Sushi Swap, then basically we'll swap on Uniswap first, and then we'll swap on Sushi Swap. And if we don't want to swap on Uniswap, we'll do the exact opposite. Swap on Sushi Swap, and then swap on Uniswap. That's how you determine the direction of the order, is basically buy on this exchange, sell on that exchange, or you buy on this exchange, sell on that exchange based on that, okay? And then finally, whenever you've done the swap, we take the token, i.e. ERC20, pass in the token address, and then we transfer to the owner, okay? The difference. So the actual profit we calculate right here, we take out the flash amount, we add 1 to pay the fee, and then we pay it back. And inside the call data, it'll take the tokens and send them back to the flash loan. Okay, so that's it. I mean, that's literally the entire function that takes out a flash loan and does an arbitrage trade between two dexes, all inside, this right here. That's how it works. So let's talk about customizing that. It's pretty easy to customize that for different tokens because you can just pass in different token addresses and the tokens basically work the same way. Okay. Now, if you're going to pass in different tokens, you have to look at different liquidity pools. Okay. But that's the router should take care of that for you. Now let's talk about, different Uniswap-like exchanges. Well, if you're doing a different Uniswap exchange, let's say you deploy it to like Binance Smart Chain, for example, you just want to pass in the Pancake Swap address right there, basically, or an AVAX, the Trader Joe address, whatever it is, right? Now, if you go to a different chain or you have to change flash loan providers, then essentially you have to change the flash loan implementation. So basically that means you don't use DYDX here. If you want to do something else, you put in somebody else's flash loan contract, and they all basically work the same. Like they all basically have a flash loan function that you call inside your contract like this. You just replace this part right here. And then they all have some sort of callback function that you have to implement on your contract after you receive the flash loan funds. So you literally just rewrite this to plug in whatever their documentation tells you to do. Okay. And then you use the same type of logic that's here and you implement that in your contract. So like, let's just say you wanted to do a Dodo, right? You just look at the Dodo documentation and, you would look at how they do their flash loan. Here's the flash loan call. Okay. You can see the Dodo flash loan sample. It won't show me right now. But basically you can see they have a flash loan function just like the DYDX does. Okay. And then you can see they've got a callback just like the DYDX stuff does. So you just got to look at the documentation and then see how to implement that in your contract and then do it that way. So somebody's going to deploy the bot to mainnet. Yes, you definitely can. So let's talk about the actual bot code itself. So bot.js. All right. So one really cool thing about the bot, I'm going to go ahead and run this. Again, if you're going to, I can get the bot to watch the mainnet. Okay. So if I go to the config.json, I can say, I can set these things to false, okay? And then I can get this to watch the mainnet, okay? So I can get my bot to sit here and watch the mainnet. And let's just see if it works. So it'll work. I just want to see if any swaps happen in real time. We can see, let's just see if there's been any swaps lately on Etherscan. So we've had some swaps inside here. We'll see if any swaps take place tonight. Because if they do take place, then we'll be able to watch them in real time on our bot. So I've pointed this to the mainnet to see if it'll start picking up swaps. We'll watch that in real time. So you can look at that in your config.json file. You can read more about that in your README here. Basically, if you look at the config.json file, it's a project settings as is local is deployed. So basically, this lets you run the bot and test it how you want to. So by default, both values are set to true. If it's local, it's false, and the bot will try to monitor swap events on the actual mainnet instead of locally. That's what I was doing just now. And if is deployed's value can be set, basically that's where your smart contract is. So if is deployed is set to true, it's for local testing. So ideally it's helpful if you want to monitor swaps on mainnet, you don't have the contract deployed. This will allow you to still experiment about finding potential arbitrage opportunities. Let's see if we got any swaps. Not yet. Okay, so let's go with the bot code inside bot.js. So, we have all the settings in the .env file, and we pull in that at the top. Okay, so we have this .env file .config. We have that config JSON file. Okay, we've got this server helpers. Okay, so basically this is just pulling in some information so that we can run our server process. Okay. And so basically everything runs inside this main function. Okay, you can see this main function. That's basically the app. Okay. And we call the main function here. Okay. And so inside the main function, what it does is it basically gets a token contract. It gets the tokens. All right. We get all that information here, and we create JavaScript versions of them, with Web3.js. Okay, so we get the pair contract for Uniswap, we get the pair contract for SushiSwap, and then we log those addresses to the console. And so what the bot does is it listens to swap events on each exchange. Okay, so like I showed you a second ago, like if I look at Shiba Inu token, all right, or if I look at any of these pools, and I look at these swaps here, okay, these are all, if I look at the logs, you can see these swap events happen, basically. So whenever something is swapped on Uniswap, all right, then it's going to emit an event on chain. Okay, the same thing for SushiSwap. So basically what we do is we look at that pair and we subscribe to the events. So we go U pair events and we look for actual swap events. Okay, and every time a swap event happens, we evaluate whether a trade can happen, because every time a swap happens, that's when potential price discrepancies happen. So basically, we say, is there a price difference? So we check the price on Uniswap for token 0 or token 1. Okay, so when you check price, we have a function out here that does that. So it says basically current block is this, and then we get the Uniswap price. We calculate that. We get the price difference. We calculated this, and then we log that to the console. So let's check on the calculate price. We've got that function. Let's just see. Actually, it comes in from the helpers, I believe. Yeah, helpers. So calculate price. Basically, what it does is it takes the two reserve amounts and then just divides them, because that's how the prices work. Okay. So we calculate price, we log it out to the console. Okay. And so once we check the price, it'll tell if there's a price difference. Okay. And then basically we determine the router path. All right. So determine direction. If price difference is greater than the difference, then we start on the Uniswap router and go to the SushiSwap router. If price difference is less than or equal to that, then we go from the SushiSwap router to the router. So basically, it's to determine the trade direction based on the price difference and the actual difference here. Okay. So if there's no router path, then there's no currently arbitraging available. All right. And we just execute and we don't do anything else. All right. Now, we can check if it's profitable. Okay. Like this, we can check the reserves, and we can get the reserves here. See here. Here reserves comes from our helpers. And so gets a get reserves, just gets the reserves from the pair contract. It logs them out. It shows you how much cryptocurrency is in there. Okay. And then basically it determines the exchange to buy is Uniswap and exchange to sell is SushiSwap. Okay. And if it's the router path is different, then you just do the opposite. Okay. And so then what it does is it returns the amount of wheat that's needed. So it gets the amount in, all right, from the router. And then it gets the amount out, all right. And it tells you the estimated amount of wheat needed to buy enough SHIB on that exchange. And it tells you the estimated amount of wheat returned on that exchange. So this is how much wheat you need, and this is how much wheat you're going to get back. Okay. And if you get back more than what you put in, that's essentially everything we're calculating here. We get the total gained. We're going to log the total gained out here. And if the amount out is less than the amount in, we're just going to skip it. But if the amount out is actually bigger, then it's going to be profitable. Okay. And that's how we calculate that profitability with the fees and everything inside that function. And so if it is profitable, then we're going to skip over this. If it's not profitable, we're going to stop and say no arbitrage currently available. Okay. But if it is profitable, we're going to call this execute trade function. Okay. So execute trade. But as it goes down here, it determines the router path. So if this is the router path, then we start on Uniswap. If it's not, we start on SushiSwap. We get the balance before and the balance after, or sorry, just before the token balance before and the ETH balance before. And then we call the arbitrage contract methods execute trade. We start on SushiSwap. We pass in that variable here. We put in the settings for the token contract address for its first token contract address for the second token, the amount we want to arb that's passed in from the function here. And then we send it from the account that we're connected to, and we actually pass in the gas value right there. And when it's finished, we say the trade is complete, and then we fetch the balances after, and we calculate that and show it on the screen, and we successfully perform an arbitrage. Okay, so that entire path that I just explained happens every single time a swap event happens on Uniswap. So every time Uniswap trade happens, we go through that entire chain to see if we can perform an arbitrage. Okay. And we also do the exact same thing for all SushiSwap trades for that particular token. Okay. So we're doing it on each exchange. We're watching that as a starting point and evaluating each trade to see if we can perform an arbitrage in the opposite direction. Because I'm watching our bot here. Does not look like we've got any trades yet. That's okay. All right, so that's an overview of how the bot code works. All right, so let's go ahead and open up some questions here. I'll take an extended time of questions before we wrap up this evening. Somebody says never put your private key in a code anyone can read. Yeah, totally. I mean, yeah, you can see, um, yeah, I don't use private keys in my coding stuff that other people can see. Bad idea in plain text. So can you do a flash on any token, or does it have to have a certain amount of liquidity? So not every token will have a flash zone necessarily. One way to get around that is basically to just swap it for whatever cryptocurrency you need. But that will also increase the gas fees, so that won't always be possible. But it is one possible strategy. Can you run the app to deploy that to a server and run the command to start it? Yes, you definitely can. How do you add the server to run 24/7? The easiest way would basically to be just convert it to like a Amazon EC2 instance, or you could run it as a node app on an easy thing like Heroku or Google Cloud Computer, something like that. Basically, everything that I showed you tonight, if you can SSH into a Linux box, you can just set up exactly what I've shown you here. How do you add other multiple tokens? So you can basically change the token addresses that I showed you in the settings there. You could run this, bot in multiple terminal tabs, okay, to basically look for new, pairs. You can run the process with different variables, all that type of stuff. You could modify the code to look at multiple pairs all at one time, or you could just, duplicate the process on different terminal tabs and look at other pairs too. There's lots of different things you could do. Someone's asking how you monitor multiple liquidity pools at the same time. It's the same concept, basically duplicating the strategy. You could basically, some of that's going to be a little bit of homework involved, but you could do the easy thing, like I was talking about a second ago, is just run the app multiple times, different settings, or you could also customize it, with some additional coding to scan multiple pairs, multiple bots, multiple pools. How do you change the amount of ETH you want to request? So that's going to depend on how much liquidity is being arbed. ERC20 token be a standard you trade with? Yeah, totally. How do you set the message owner to be a specific ETH wallet? So you could basically go into the contract and then change the owner here. You could literally just paste in an Ethereum address. Somebody says VM exception while processing transactions max fee per gas is less than the block space fee per gas. Try using the exact same truffle version that I am. So I had to do this earlier when I ran through the example. I got that exact same error. I just did this. I did npm uninstall --g truffle, and then I did npm install --g truffle, at version 5.5.11, I think is the version. Let's just look. Yeah, 5.5.11. Is there maximum minimum gas you'd like to have I don't understand the minimum gas. Yeah. Should newbies me be playing with this? That's a great question. So, I would say here's the great thing about this opportunity. let's say that, in the very least, I would definitely take the time to go through the example that I showed you here. So let's say you decide not to like try to become a competitive arbitrager or like on the main net and go after like creating your own strategy. This is an amazing portfolio opportunity. So let's say you're trying to become a blockchain developer. If you understand how this works and you can convince someone who's hiring blockchain developers that you understand how this bot works and that you did something and made it happen, like that's probably going to get you hired like instantly. So so the question is, should a newbie be playing with this? Um, you know, I think so. I mean, let's say you don't decide to go pay a bunch of money to put your smart contracts in the main net, but you still want to like run the bot on your computer and get familiar with how it works. Like that's a huge value. Is there a way to do this in C++, Java, or C Sharp? Definitely yes. You can basically run the bot that way. Now you've got to make sure that it supports a way to talk to a blockchain node. So I don't know about the libraries for C++, but I mean you could theoretically always like just make RPC calls directly, but that kind of sucks. I would stick with JavaScript or Python. Does gas come out of a wallet for the trade? Yes, that's where the gas comes from. So where are we migrating this contract to deploy to the wild? Doesn't seem like I can just paste in my MetaMask account and number go. How does it get my gas if there is a failed transaction? Yeah, it's a good question. So basically, you have to add your account to the project, okay? And then you have to deploy the smart contract to the blockchain with Truffle, like I showed you before. And then that's uh, that's how it works. So what's the gas cost range? Yeah, the great answer in the chat there is just run a function that gets the current gas fee. That's a great answer. So how does the transaction get signed? Where are the private keys for the caller? So basically what you're going to do is add your so Justin and I were talking about this earlier today. So if you have a follow-up question on this and you want, Justin is making a update to this to sign the transaction with the private key directly inside the main bot file. So if you're inside the blockchain mastery program, definitely check that out. But the whole idea is that you're going to be signing your transactions from this account here. Okay. And that account's going to get pulled in from the top of the file, process.env.account. So what you can easily do is when you add your Web3 connection, basically you would just add the account to the Web3 connection wallet with the private key. It's pretty simple. It's like a one-liner. So what changes need to be made to make this work on Polygon? Which code parts need to be replaced? So, I mean, there will be several things, but like it's pretty close right now. So basically, you would need to implement a flash. So first of all, you have to make sure that both exchanges that you want to arb for on Polygon are, Uniswap version 2 clones. Okay, so I mean, the good news is you've got lots of options. I mean, there is an actual Uniswap version 2 on. I mean, there's a sushi swap on Polygon. There's a quick swap on Polygon. There's an ape swap on Polygon. There's lots of Uniswap version 2 forks on Polygon. Okay, so basically, those addresses. You would need to change the flash loan provider. Okay, so I'm gonna leave that up to you as some homework to look at that. But basically, you swap out the flash loan provider from this DYDX provider here. They all, like I showed you before, like they all basically work the same. They all have a flash loan function, which you would just swap out here. And then they all have a call E function that it has to be implemented on your contract. And you'd swap that out here. And then you would basically do the trades that way. And then you would update your bot script with any settings that might change based on that. So gas fee, are you paying one time to swap on you, then one time on sushi swap and flashline? It's all in one go. So Python question mark, yeah, you can definitely do it in Python. Does bot connect to a wallet? Yeah, it definitely can connect to a wallet. So how does a transaction get signed with a private key for the caller stored? So definitely go check out what I was saying a minute ago about that. Hasn't how much to borrow, however much is in the lowest liquidity pool. Yep, that's the idea. So they're running an ETH node. Do they still need to run Truffle and Ganache? Nope. If you're running an ETH node, then you should be able to do it on your ETH node. How do you set the trader bot to another RPC for sending transactions? Yeah, it's a good question. So that's the .env files for. So if you go in here, you do Alchemy API key, you can do that. Okay. You can also in the bot script, if you don't want to use Alchemy, okay, you can basically, okay, you can change it. It's inside helpers. You can change your RPC URL here. How much was the flash loan fee, as an example? Right here. Here's the gas spent, 0.006 ETH. $18. Can we add events and use those in a UI? You could do that, but I wouldn't try to like click a button in a UI to do a swap. I would just let the bot do it. What kind of compute power is required on this bot in AWS? Not very much. Does the bot consider profitability after gas? Yes. So the flash loan fee with DYDX, I should have mentioned this. The flash loan fee is basically nothing. So for the flash loan fee for DYDX is paid in like one way of the cryptocurrency you're borrowing. So like if you're borrowing ETH, you just have to pay like 0.00000000000000001 ETH. It's basically negligible. You just have to have a little bit of ETH. So is MEV on L2 profitable? So the question is my, so like if you're talking about monetizable value in terms of arbitrage, so doing it on L2, I guess, is that the question? ETH for Earthweed sounds like when Patrick from SpongeBob got East and West mixed. That's awesome. Common mistakes that can happen other than gas fees mess up. I mean, probably the most common thing you're going to run into is other people executing on trades before you. So, you can try to fine tune your strategy to get that faster. You try to use front running protection if you're running into that issue, or you can do like I was saying before and just try something else. All right, just a couple more questions here, then we're going to wrap it up for this evening. How do we know who's offering Flash at the moment? You can use a lot of different Flash loan providers. You can look at DYDX. You can look at Aave, like I was saying before. Aave's got higher fees. You can look at Dodo. They're free, but Dodo's a little harder to work with, in my opinion. That's why I like DYDX. Give some hints on profitable Flash loans. Definitely check out DeFi Llama. It's a good hint right there. What does TVL actually mean? Basically total value locked. So it means all the cryptocurrency locked into a particular protocol, the USD value added together. So thank you for the lesson. Give us a shot. Extremely informative. Awesome. Glad you liked it, Marcus. All right, everybody. So that's all I got for today. If you got any questions, go ahead and drop those inside that blockchain mastery community. If you're not into the blockchain mastery community, you can hop in there. We got lots of people helping each other out. Definitely shoot an email to gregory@dappuniversity.com. If you joined tonight, you're not a part of that membership, get access to all those benefits like, weekly updated videos, all the past master classes we've done, all the future master classes. It's absolutely insane value. So, also, if you want to learn more advanced coding so that you can build this bot yourself, the Blockchain Bootcamp is the best way to do that. It's the step-by-step coding program that shows you how to become a real-world blockchain developer in a matter of months. There's a discount code to join tonight. All right. So we got one last question here. If I'm still running a node, do I need truffle or ganache? So no, you do not need truffle or ganache for running your own node. So anyways, that's all I got for tonight. Thanks for a great class, everybody. I know I had a great time. And until next time, thanks for watching Dapp University.